Hello everyone, this is Dr. K. Shaktiraj working as an assistant professor in Kamaraj College of Engineering Technology. In this video, we are going to discuss about detection of ultrasonic wave. Before enter into this video, I would like to give some introduction about ultrasonic wave. As you know very well about, ultrasonic wave is a high frequency sound wave which can able to travel in a straight line with appreciable loss of energy. This wave it can able to diffract, absorb, scattered, interference like ordinary sound waves. We cannot able to see such kind of waves, and the energy of the wave which is highly depends on their frequency. As we know very well about it, their frequency is very high, so that the energy of the wave is very large. Today, our aim is to determine the detection of ultrasonic wave, and here we can see that 4 different type of detection methods are available. One is called Kunst tube method, second one is a thermal method, third one is a sensitive flame method, and last one is a piezoelectric method. Before we deep dive into this topic, first we should get some idea about the standing waves. So, what is meant by standing wave? Here you can see that is one string. The stretched string is held at one end and the another one end is fixed. When we give some small vibration to this wing, it creates some progressive wave. When that progressive wave reaches on the target, it produces secondary waves, right. So, that in this case here we have a 2 different type of waves, one is called the progressive wave, another one is a reflective wave. These 2 harmonic waves are superimposed, we get the standing wave pattern, and both the waves are travelling in an opposite sense. So, that the simple definition for standing wave, which is nothing but is a superposition of 2 harmonic waves which are travelling in a opposite direction, right. This particular animation will clearly explain what is going on in the standing wave. Here you can see that is our progressive wave and that is our reflected wave. When these 2 waves are superimposed, we get a standing wave pattern like this. In this pattern, we can clearly see that at one particular point, the displacement of the particle is totally nullified. So, that destructive interference will be takes place at some position, that position is we call it as node. At some particular position, that is the amplitude of the wave or the displacement of the particle is rigorous. At that point we call it as anti-node. So, the entire standing wave pattern consists of lot of nodes and anti-nodes. Next, we are going to analyze the compression and rarefactions present in the standing wave. As we know very well about it, this is our standing wave. Here you can see that the pressure variation present in the standing wave. As I mentioned earlier, at nodal point the particle displacement is 0. At antinodal position the particle displacement is very large. So, at antinodal position particles are always changing their position to the nearest nodal planes. So, that nodal planes are always suffer from compression and rarefactions. So, that nodal plane at nodal plane compression and rarefactions are always happens. So, here you can see that is one nodal plane. Now, here consider one particular point, this particular dot it does not affect by the vibration created by the external source, and here we can consider other than one red spot. Now, that red spot it can able to vibrate from their equilibrium position. So, from this case we can clearly see that nodal plane pressure is always shunting between the positive peak and the negative peak, but the anti-nodal position the pressure variation is always very less. With these basic information, now we are enter into our first type of detection method, that is called Kunz tube method. The Kunz tube, which can able to construct with the help of 1 meter long quartz tube, and one end of the tube is fitted with a movable piston, right. The another one end is fitted with a stable piston, and inside the 1 meter tube we have to fill with some amount of lycopodium powder, right. And during the experiment, from the one end we are sending ultrasonic waves through the quartz tube. Then the ultrasonic waves reaches on the movable piston, some kind of reflector, ultrasonic reflector is fitted on the movable piston, so that the ultrasonic waves get reflected back to the same direction which they are originated, right. So, the transmitted and reflected waves both are interfere, we will get a standing wave pattern. So, the standing wave pattern definitely consists of two different type of points, nodal and antinodal planes. In this case, we can see that this is our nodal plane and this is our antinodal plane. Few slides before I mentioned you nodal planes, particles present in the nodal plane, it does not move much higher than the particle present in the antinodal plane. So, that the lycopodium powder which we spread inside the column, which are collected at some particular region, especially at nodal planes, because there the particle movement is very less. Antinodal particles, antinodal position, particle movement is very high. So, that the lycopodium powder are trying to collect on the nodal planes, and the distance between the two nodal planes, that we call it as D, which can be easily identified from the distance between the two heaps. Now, we know very well about lambda naught is nothing but is a wavelength of the ultrasonic wave which we are sending inside the Kunz tube, right. So, that lambda naught is related with a D, that simple formula, that is lambda naught is equivalent to 2D, right. That particular experimentalist, it simply demonstrate how this different type of waves, simple first harmonic, second harmonic and third harmonic waves are projected inside the Kunz tube, that will be discussed. And from this case we can see that the D, here D is nothing but is a distance between the two nodes, which is related with a lambda with a formula called lambda naught is equal to 2D, and the velocity of the wave, which is measured from the formula V is equivalent to F into lambda. So, with the help of Kunz tube method, so how can we detect ultrasonic wave from this? Suppose if the tube, it does not have any ultrasonic wave, all the lycopodium powders are evenly spreaded inside the quartz tube. If the ultrasonic waves are present, it form a heaps. So, with the help of this, we can easily visualize the ultrasonic waves present on this particular area or not, that can be easily measured. But at the same time, the velocity of the wave which is passing through the Kunz tube, which can also measure from this formula. Next, we are going to discuss the second type of ultrasonic detection method, which is very simple method, that is called sensitive flame. You can see that some kind of ordinary Bunsen burner, we have to take it here. We should control the surrounding environment. The flame should not be affected by the external influences like wind blow or any other kind of parameter, physical parameter which can affect the flame. So, that under these circumstances the flame, it form a stable shape. But when ultrasonic wave passes through the flame, it will get flicker. So, why it get flicker? The main thing, when ultrasonic wave passes through a medium, definitely it form alternative compression and rarefactions. So, that due to the variation in air molecule, it form a flickering. So, that which is another one very simple method to detect ultrasound. The third method, which we call it as thermal detection method. with the help of this method. I think you know very well about the circuit, that is Wheatstone bridge, that is mainly used to measure the small unknown resistance connected to the any one of the 4 arms. You know very well about the structure of this circuit, it will contain 4 resistances. If all the 4 resistances are equal, here we have to connect one galvanometer. The galvanometer it show a null deflection. If any one of the resistance is slightly varying with respect to the another 3, some amount of current will be flowing through the galvanometer. So, definitely it shows some deflection. So, that in this particular circuit, so it is a simple circuit which is used to measure the unknown resistance. In our case, how can we convert the circuit to the ultrasonic wave detection? Simple thing. In this variable, instant of this variable resistance, we simply replace with one fine platinum wire. We know very well about the property of platinum wire. It's a good conductor. Even it is a good conductor, it have a very small amount of resistance. That resistance could be varied with the help of temperature. So, that this particular part is replaced by a fine platinum wire. If there is no initially the P, Q, R and the resistance of the platinum wire, all the values must be equal. So, that the galvanometer it show a null deflection. When ultrasonic waves are passes through the platinum wire, what is happen? As we know very well about it, it form a standing wave pattern. Due to the formation of standing wave pattern, it form alternative compression and rarefactions, right. So, due to the alternative compression and rarefactions at nodal plane, compression will form. That compression increase the temperature on this area. So, that at a nodal plane temperature will be raised. So, that the change in temperature directly affect the resistance of the platinum wire which we are connected on the position S. So, that the bridge balancing condition would violate. So, that automatically the galvanometer it show a deflection. When we switch off the external ultrasonic wave, what is happen? Automatically the galvanometer come to the null position. So, that is another one simplest method to determine the ultrasonic wave presence, right. And the last method, that is called piezoelectric detection method. As we know very well about it, the piezoelectric effect, that is nothing but actually the piezoelectric effect exists only in certain type of crystal like quartz, tourmaline, rock salt. When these kind of crystals are subjected to a pressure on one pair of opposite faces of quartz crystal, equal and opposite charges are induced on the other pair of opposite faces of quartz crystal. With the help of this effect, we can easily detect the ultrasonic wave. How can we do that? Simply, that is one quartz or tourmaline crystal. When we apply ultrasonic wave through the path of this crystal, automatically due to the presence of ultrasonic wave, it form alternative compression and rarefaction. That compression and rarefaction produce some mechanical stress on the crystal. So, due to the mechanical stress on one side, it produce a voltage difference on the other pair. That voltage difference can be easily sensed with the help of voltmeter. So, when ultrasonic wave passes through it, voltmeter show a deflection. When there is no ultrasonic wave is there, the voltmeter show a null deflection. With the help of this, we can easily detect the ultrasonic wave. I hope all of you are enjoy this session and you can get all the points about how to detect ultrasonic wave. So, thank you so much for watching this video. Once again, we will see you on our next video. Thank you.